Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, today we'll discuss about the JEE Advanced 2014 Physics Paper 1 question paper discussion. Today we'll discuss about question number 9. So let us discuss what is question number 9. Students, let us solve question number 9 of JEE 2014 Physics Paper 1. A transparent thin film of uniform thickness. Transparent thin film of uniform thickness. Here is a thin film as shown in black shaded region here, black region here, and refractive index of this thin film is 1.4. This says 1.4. Is coated on the convex spherical surface. So there is a convex surface like this on which the film is coated, and that convex surface is made up of glass obviously, and of radius of curvature r. So the radius of curvature of this part is r. At one end of a long solid glass cylinder. So this is basically a solid glass cylinder like that, and we have something like that glass cylinder, and this one is convex. You can see that this is convex, so like that. So this is cylinder, so this one is convex, so one face is convex, and the refractive index of that N2 is 1.5. that is given as shown in figure. Rays of light parallel to the axis of cylinder. So this must be the axis of the cylinder, and the ray must be coming parallel as given in the question. And then the ray is traversing through film from air to glass. So from air to the film, and the film to the glass. So this way it finds changing the media. One in medium is air, the other one is film, and the third one is the glass. So there are three medium present. So it's moving from air to glass, and get focused at at a distance f1 from the film. So from the film it is focused at a distance of f1. So the image that is formed when the rays coming from air first incidents on the thin film, then you find a glass, and finally focused at a distance f1 from the film. While the ray of light traversing from glass to air get focused from glass to air, the reverse way, if we allow the light to move parallel to the axis and from glass to come out from the air, then it is focused at a distance f2 from the film. So from the film it is focused at a distance of f2. So it is from somewhere f2 from this here. Then which of these are or is correct? So basically he's interested in the magnitude of f1, the magnitude of f1, the magnitude of f2. So basically he wants to find f1 and f2 and see which of the result is correct. So we have to find f1 and f2. We must remember that these f1 and f2 are the images formed respectively when the ray moves from air to glass or glass to air respectively. So we'll consider the first case, that is for f1, when ray of light is traveling parallel to the principal axis of the cylindrical shape or convex shape faced surface, and gets focused at the inside the the glass cylinder. So we'll draw a diagram something like that. This is a convex surface, and this is the cylinder, and you can consider this as the axis, and the rays are coming parallel. I'll take black color for the ray of light. Rays coming parallel. I'll take only one ray. There may be infinite number of rays. So to understand that the rays coming parallel, so and we must have a layer here, that I will also draw the layer over here, because there is a layer here, thin layer, that also we have to consider. There is a thin layer here. This is a thin film whose refractive index is different from that of the glass one. Its refractive index is 1.4 and the glass refractive index is 1.5. This we have called N2 and this we have called N1 as shown in figure. This is a film. This is of glass and this is air. The light is traveling from air to glass through this medium, film medium. So we have to bifurcate the separate to the analysis of first the light moving from air to the thin film. If in case that glass is never present, we only think that air to the thin film, then there must have some image somewhere, and only when this is present, so that we'll consider. And the image that is formed only because of the presence of the film, it will act as the object for the lens. Okay, so let me repeat that. If in case only this thin film is present, then the ray coming from air and incident on the film must have focused at a point, because this is convex, so it must have focused somewhere here, this side, and that would have been the final image. But because we have another glass over here, so there is another medium, so the image that would have been formed by the presence of film alone will act as the object for this convex lens of the cylindrical glass. So therefore the image will be further shifted, will be formed somewhere else. So we have to use the refraction of light at the curved surface, single curved surface, two times, one for this air to film and then for film to air to glass. So two times we will apply the refraction formula at the curved surface. So let us first apply the formula for that refraction. That refraction refraction at a single curved surface. So we have a formula for a single curved surface. If we have a curved surface like this, whether it is convex or concave, that formula is still valid. So but you can prove at your own, but then this formula you have to use it. This if I take a point image or anywhere image and the ray goes like that and finally incident here, so from here this is air, or suppose this is glass or any other medium, is refractive index n1, refractive index n2, then I would have written this is the object distance, this is the image distance. The formula is n2 over v minus n1 over u equals to n2 minus n1 divided by r. This is the formula that we are going to use for that surfaces. Now if I use this formula, we have to keep one thing in mind, that this n2 is always the medium, refractive index of the medium to which the light is reaching. and this n1 is the refractive index, the medium from which light starts traveling. So if it is air to glass, this will be glass, this will be air. If it is glass to air, then this will be your air and this will be your glass. That you must keep in mind. And V and U are the respective object and image distances formed. With R, you must take with the proper sign, positive and negative. So this U, V and R are with taken with signs. With sign you have to consider. So if I apply this formula to this situation, what will happen? Let us see that if I apply the formula to this situation, my situation is air to film. So if I apply air to film, then what will happen? So the ray I am considering is traveling from air to the film of here the refractive index is 1, here the refractive index is 1.4. So for me this is n1 and this is n2 for this case, not with this case of n1 and n2. So if I use this and I have the equation of n2 by v minus n1 by u equals to n2 minus n1 by r, and if I use it here, n2 is my second medium is this one, so I'll write n2 is 1.4 divided by the final image where it is formed, I don't know, so I'll write that image is v, because I don't know so where the image is going to be formed. I will just say after finding the value I can just draw the diagram, but it is not required right now. So minus n1 is 1 because refractive index of air is 1, divided by u because the rays are coming parallel to the axis of this cylinder, so therefore this must be coming from infinity, so u must be infinity. So if I consider u as infinity here and n2 is 1.4 minus 1 divided by r, this r is positive because you can see here this is if I complete this will be a sphere over here, and from here the center is lying right to this, right side to this, so therefore this distance is positive, so r is taken positive. U is negative, but then it doesn't matter, it has to be infinite, it has to be 0, and final image must be somewhere here. That is our intuition, but then we'll see whether it is from there or not there. Now this is positive, obviously you can put plus r to keep reminding yourself. This is the better way of writing things, because r and plus r, if you write plus r, then that will keep you reminding about the sign convention that is supposed to be taken in this case of in this formula. So therefore if I solve that, I will have 1.4 divided by v, this becomes 0, this is 0.4 divided by r. From here if I want to write the value of v, then it will be r 1.4 divided by 0.4, so this is 14 by 4, this is 7 by 2r. 7 by 2r, or I can say 3.5r. So that means if I just help you understand the image that is formed here, suppose this is my r, suppose that this is r from here to here, this is the radius of curvature of this, then it is 3.5 r that is coming as 1, 2, 3 somewhere here. So only when that this is present, only in the presence of thin film, if this is not there, the ray would have finally come to meet at this point, and one ray which is coming straight parallel must have gone straight, because this is the normal direction, and the ray is not going to change the direction in case of normal incident, so it have gone straight and meet somewhere here. This would have been the image I'll call say I dash, point image obviously, and but this is not the final image, and that we have calculated here as v, and that is we have got as 7 by 2r. But then this object, the image found by this one will act as object for this glass convex lens or something like that, because I can call this as a convex lens, because that is bounded by one curved surface. So this will act as a point object for this one. So I have to use this distance, which is the image distance of this film. I'll consider this distance as the object distance for this one. If I consider object distance for that, then I will have another situation. So I will write that situation now. Now we have a situation when ray is traveling from film to glass. Finally it has to land on glass. So from here to here, the film I will consider N1, this one I will consider N2, because N1 is the medium from which light is traveling, and this is the medium, second medium to which light is traveling. From this medium to that medium, the 2 is N2. So here film is 1.4 and this one is 1.5. Now in this situation I will use the formula again, N2 by V minus N1 by U equals to N2 minus N1 by R. Now in this situation, when the ray is traveling from the film to glass, then the image that was formed earlier will act as object. So here it will be the object distance of where finally it will form, I don't know, so I'll write this is second medium 1.5 divided by V dash. I don't know where it is formed, so that is the unknown. Minus N1 is 1.4, and the object distance is the image that was formed earlier, that was 7 by 2r, and this equals to, and obviously that is positive, that also keep in mind, this is positive, this is required, so we don't know whether this is positive or negative, so that will keep as it is, and this is 1.5 minus 1.4 divided by r. This r will be positive because that is your right side, it is lying to the right side, so it is positive because in the direction of ray it is happening, so it is positive. Now if I solve that, I will get from here, I will write one more step here, then I will move to the next page. Just simplify that. This is 1.5 divided by V dash minus this is 2.8 divided by 7r equals to 0.1 divided by r. So this one, if I solve, I will have multiply 10 over there. This is 15 by V dash minus 28 by 7r equals to 1 by r. What I have done, I multiply 10 throughout the equation, and this becomes 4. So 15 divided by V dash is 4 divided by r equals to 1 divided by r. So from here I will write 15 by V dash equals to 4 by r plus 1 by r, that is 5 by r. So 15 by V dash is this, and V dash equals to 3r. 5 3 are 15, 3, so it will cross multiply, and this is the V dash. That means the final image is formed at V dash. That means if I now finish the formation of image after refraction through this one, it is 3r, earlier it was 3.5, so it will be now 3 somewhere here. This is the final image formed, and that distance is coming out to be 3R. So if I remove the glass and think only of the thin film, the image would have formed here, which is at a distance of 3.5R. But because this is present, the image is formed at a distance, finally at a distance of 3R from the film. So this 3R is the distance f1 that is given. Okay, so brother, I would say it is the focal length of the thin film and glass combination, because the parallel ray is supposed to be focused at a point and it is focusing here finally. Therefore, it is the combined focal length, I suppose. But then I have to check it. But anyway, because that is not our concern, our aim is only to find this f1, which is given in our question, that this distance where it is finally formed is f1. So finally we got f1 as 3r. So in the question it was given f1 and f1, we got 3r. So this one is f1 in our question, and that f1 comes out to be 3r. Obviously it's positive. Even if I take the magnitude of that, then also I'll get 3r. If I see the option, then f1 magnitude is 3r, that is correct. So first option, this one is obviously wrong, because that is also f1, which is not. This 3r is correct. Then we have to see the f2 part, when the other side of the situation, when the ray is reversed. The ray is reversed, ray traveling from glass to air. Now in this situation we'll see what will happen. Now in this situation, when the question, I'll just tell you once more for that the ray is traveling in this case from glass to air, then what will happen? Now while the rays of light traversing from glass to air, now the direction is reversed. It has to be moving from this side to the other side, get focused at f2. So final image is formed at f2. F2 is the final image that we have to find and see which one of these is correct. So basically what we are doing is we are just repeating the things with reversing the direction of the ray. So now if we think this is the situation earlier, and the thin film was over here, this was the thin film region, it was here, and so that was the situation. And this was the axis of this situation. I consider a ray coming parallel again, that I have to consider parallel rays, because nothing is mentioned, so I will consider that the rays are always parallel. If the rays are parallel, they are supposed to be focused over here. So I will consider the situation that here, in my case, this is N1 and this is N2. So I'll consider that when the ray is traveling from glass to film and then to air, here I'll apply one formula, then here also I'll apply formula. So twice I'll apply the formula. So here my formula I will apply. First case is case 1, when the ray of light is traveling from glass to film. ये बंद क्यों जाता है बार-बार?
बंद करके चालू करो।
खराब हो गया लगता है ना, तब बंद हो जाता है।
मतलब ज़्यादा ठंडा हो गया ना?
ज़्यादा ठंडा होगा ही नहीं, गर्म
तो आपका आप तो लाल हो गए।
तब ठीक नहीं ना?
पूरा लाल हो गया।
रेड दिखेगा इधर।
पूरा लाल हो गया।
Continuation of this question number 9. Case 1. So the ray is traveling from
Also, start.
So the ray is traveling from glass to film. So first of all, we'll consider this situation traveling from glass to film. So here the glass is having, I'll consider this as N1, this is I'll consider N2, this is 1.5, this is 1.4. This way if you write there is no confusion, and this way. So I'll write that N2 minus N1, N2 by V minus N1 by U equals to N2 minus N1 by V. In this situation, if I N2, you can see here it is 1.4 divided by V. The V is the image that is formed, that I don't know, I'll consider V only, no problem that. Then next is N1 is 1.5 divided by, because it is coming parallel, the first medium the ray is parallel, so U is infinity. So then I'll consider infinity here. 1.5 minus 1.4 minus 1.5 divided by, this is obviously R, not as V, this is R. Now this is R, so I will consider R is positive or negative, because the ray is coming in this direction, the ray is moving in this direction. So any measurement that is done in this direction is positive, and any measurement in that measured in this direction is negative. So this direction is negative, and the radius of curvature is to be measured from here towards this side. So this will be negative in this case. This is important point. This will be negative in this situation. So it will be minus R for this case. If I solve that, this will become 0, because 1 upon infinity is 0. So this is 1.4 divided by V equals to, this minus multiplied here, it is 1.5 minus 1.4 divided by R. So from here if I write, then this is 1.4 divided by R, this is 0.1 divided by R, so it's 14, and this is 1. So this is V, this is V here, so it is V here, so 1.4 by V here, so 0.1 by R here. So from here V by R is 14, that means V equals to 14 R. This is the image formed by the ray, by the ray for the object. When the rays are coming from infinity, is the image of the object formed at this point, 14 R distance from the film, 14 R distance. But then this 14 R, so 14 R is coming out to positive, that means the image is formed in this side, not here. So I suppose that the image is formed somewhere here. This is the V distance that I got now, and that is 14 R. But then this image that is formed is not the final image, because we have got thin film. So because of the presence of the thin film, this will get deviated, might be somewhere here or might be somewhere here. So the final image will be not exactly at a distance of 14 R as seen. It might be less than 14 R, it might be greater than 14 R. That we'll see now, and we'll also logically talk about whether it will be less than 14 R or greater than 14 R. So another situation we have to consider. Now that the 14 R that is formed, we'll consider the situation, that the one situation we have already considered, this one from here glass to film, we got V as 14 R. Now this VR will be treated as object for this situation. So if I see this situation and apply the formula once more, my ray is traveling from film to air. So here my this N1, there it will be N2, my film is 1.4, this air is 1. Now, if I apply the formula, same formula I'm applying, and I write n2 by v minus n1 by u equals to n2 minus n1 by r. Now, the situation is that n2 is this one, I consider 1 divided by final volume that that is formed is suppose v, or v, no problem, that v, final v, minus n1 is 1.4 divided by u. U is the this one will act as u, object distance 14r. So this is 14r. We have to keep in mind that if I have taken here as here I've taken this distance as a v, so I will consider this distance as something else, say v dash. This is the final image formed, because the v I have already used, so I'll take v prime. This becomes n2 minus n1, which is 1 minus 1.4 divided by r, but in this case r is negative, just like the earlier case. This is minus r. If I solve this, then this is 1 upon v dash minus, this is 1.4 divided by 14r equals to minus 0.4 divided by minus r. This is plus. If I multiply 10 throughout the equation, then I'll have 10 divided by v dash equal minus 14 by 14r equals to 4 by r. This 14 and this 14 will cancel. 10 over v dash equals to 4 by r plus 1 by r. So this is 5 by r. If this is 5 by r, then 10 by v dash is ultimately 5 by r. 5 to the 10, v dash is 2r. If v dash is 2r, that means I will write see through the diagram where the final image is going to be formed. It is saying 2r. 2r means this is too near, this is 14r is so far. So somewhere here, finally the ray will get focused here. This is the image formed. These rays are meeting here, and this is the position of final image. So if it is the position of final image and this distance comes out to be 2r, in the question paper it is given that this final distance is f2. So we are getting finally that this is my f2. So this f2 is 2r, and it is positive. Even if I take the magnitude, it will remain 2r. So if I check the question, which one is correct, if I look at the question here, you can see that the magnitude of 2 is 2r. This is correct, and this is obviously wrong. So this is 2r is correct. So we have got two options correct. That option number 1 and option number 3, where magnitude of f1 is 3r and magnitude of f2 is 2r. This is the answer to this question. Okay, thank you.